All right. So the purpose of this little demo is just to show you some basic Python functionality that you may or may not be familiar with for exploring and visualizing data. Okay. Now, there is no like step-by-step procedure for exploratory data analysis, because one of the things you're doing is looking for problems in the data. And there is no exhaustive list of problems to look for or exhaustive list of ways to find them. But the main idea here is you want to load in the data, think about what your assumptions about the data are, and then look at the data and see if it kind of is consistent with your assumptions. So the data we're going to use in this example is a data set about pedestrian traffic on the Brooklyn Bridge, which is located right near our Brooklyn campus. And it's a bridge that connects Brooklyn and Manhattan. It has a vehicle section, a biker section, and a pedestrian section. And when the tourists are not around, it's a good place to go for a run. Suppose you want to create a machine learning model to predict the volume of pedestrian traffic. And you have this data set here. It's available from the New York City Department of Transportation. And you think it could be helpful for that purpose. Now, there's some documentation about this data set here. So I'm going to fill it in. Okay, let's start. Step number one, we'll load in the data. To load in data, we're going to typically use a library called pandas, which is going to be imported with the PD alias. Okay. And it includes many functions for reading in data in various formats. For example, you can read from a database, read from an Excel file. In this case, we're going to read from a CSV file, which is a kind of flat text file. And we can actually call this read CSV function and just pass it the URL of the data. So I'm going to do that directly. I don't even need to download the data first. I'm going to have it read in the data. Now, sometimes your CSV file might have, let's say, different parameters. For example, the data fields might be separated by tabs instead of commas. There might or may not be a header row. So you might need to pass different arguments to this function besides for just the URL of the data. And I'm going to take a quick look at the data to make sure that I didn't have such issues. For example, if I loaded it in like this, let's say with a new line separator, for example, then I'd have all of the data all kind of jammed into one column. Or if I loaded it in like this, telling it there is no header row, it doesn't like that. Sorry, none. So if I tell it there is no header row, then it's, you can see, misinterpreting the header as a field of data. So just after I load in the data, I'm going to look at the first few rows of the data using this head function to identify possible problems like that. Okay. So anytime column names or row names are not loaded correctly, if everything's jammed into a column, if the first row of data is actually column labels. Let's also check the shape. So we can find out the number of rows and columns. And if we look at the data source, we can see here it says there should be 16.1K rows, 12 columns. I'm going to share this link with you so you can go ahead and kind of look at some information about the data set too. Okay, so that checks out. This rounds to 16.1, and there are 12 columns. Let's take a quick look at the column names and types. Open this side. Okay, so these are the column names I read in. I'm going to compare this to what it says here. So location is a text field. That seems good. Then I have a number of pedestrians. It's a total count, so the sum of pedestrians in both directions. That's a numeric field. Yes. Going towards Manhattan, this is a number of pedestrians crossing towards Manhattan. That's also numeric. And then the number crossing towards Brooklyn, also numeric. I have a weather summary. This is a text string. That tells me the overall weather that day. I have a temperature, which is hourly temperature in Fahrenheit degrees, also numeric. Precipitation, so how much precipitation in inches fell that hour, numeric. I have latitude and longitude. I have a text string that indicates whether there's any special event that day. And then I also have a location field. Looking up, I can see it's basically the latitude and longitude together. Okay, so far everything checks out. What do you think it might mean if, let's say I looked at the pedestrians field and instead of being loaded in as numeric, it said object, meaning it loaded in as a string? What might be a reason for that? Any ideas? So a lot of these libraries, exactly, as Ben said, a lot of the libraries basically look at the data type in a column to determine how to read it in. If some rows have text in that field, then it's going to read in the entire column as a string. Now, you wouldn't expect to have text in any of the pedestrians field, so that would be a sign of some problem with the data. Maybe something was entered wrong or something was processed wrong, and that would be a red flag to look at. Okay, next we're going to do a summary of the data, how many values are in each one. Okay, so let's see, we have in these fields, so the hour, location, number of pedestrians and pedestrians in each direction. We have 16,057 non-empty entries. In the weather-related fields, we have 16,041. In the location-related fields, again, 16,057. And in the event-related fields, we have 1,124. What does this tell us? Okay. So this tells us that some of these fields, let's say, so we know there are 16,057 rows in the entire data set. But this is telling us that the weather-related fields are empty for some of the rows. Right? So this tells us that 16 rows are missing weather data. What about events? So I only have about 1,000 rows with a non-empty event field in this entire data set. Is that bad? Okay, so most rows are not expected to have some sort of special event, so that's normal. Okay. Let's see if we can correct that. How would we go about correcting, let's say, this problem where 16 rows are missing weather data? What can we do about that? So one option would be to drop the weather-related columns completely. I don't necessarily want to do that because I want to use weather as a feature for predicting pedestrian traffic. Ben suggests fill in with a logical value. What might be a logical value for weather? So I could use a mean, but that would not necessarily be a good idea because I have a better choice here, which is to fill it in with an adjacent data field, meaning the weather at time t is very similar to the weather before, the weather after. So I can just carry that value forward. It will probably be reasonably close. Okay. So let's try that. Now, in order to do that, we need the data to be in order, right? In order by time, in order to fill a time field forward. And looking back here, we can see it's not ordered by time, right? So this is definitely not an order. So before we can fill in missing data from adjacent time rows, we'll need to order by time. Now, we actually had a date time column field called hour beginning, which includes a complete date and time, but it was read in as a string. In order to order by time, I want to convert that to like a date time object. So I'll do that. I'm going to take my hour beginning field and I'm just going to convert it to a date time object. Okay. So now you can see it's read in as a date time. And now I'll sort it by that field. Okay. And now you can see these are definitely sorted in order. Now, for our analysis, while we're on this date time field, for our analysis, we might want to predict pedestrian traffic by time of day or by month. For example, there might be more pedestrians in the summer than the winter. So in addition to this hour beginning field, we can also extract an hour, month, date, and dating field using the pandas date time functions. So I'll do that now. Now, I'm showing you these not because you need to memorize any of them. I don't need you to memorize any date time functions. I just want to show you that these libraries have functions available for doing a lot of common data analysis tasks. So if you're trying to figure out, let's say, how to get an hour out of a date time field using pandas, well, if you type that string into Google, you'll probably find out pretty quick. Okay. So now I have my data set. It's sorted in order of timestamp. And I also have a month, date, and date time field. I'm going to check and make sure I have everything. So do you remember, we talked about data sets that are missing rows completely, right? Here we have a kind of range of the data set. It goes from October 2017 to December 31st. And we'll look for missing rows by checking if there are any dates or hours anywhere in that time range that are not represented in the data set. So to do that, I'll use this date range function to produce a list of all the hours in that range, and then see if any of them are missing. What do we see? Okay, so this analysis shows us not only was our data set missing some values in some rows, like missing some weather values, it's also completely missing what appears to be August 2018 through December 2018. Is there anything I can do to fill in that missing data? Okay, probably not. I agree with Ben. Okay, but it's just good to know if we decide to use it. Okay, so this is the list of missing dates. Okay, now we'll go ahead and try and fill in those missing weather data. So we could actually look and see how many are null in each field. And we see what confirms what we found before, which is that 16 rows are missing some weather data. And these are some examples of these rows. Okay, and we can see everything else in them seems reasonable. There is no obvious reason why they should be bad. There may just have been some problem in recording the weather at those hours. So we're going to go ahead and use the pandas fill NA function to carry the last valid observation forward. And we could do this because we've sorted by date already. So now I'm going to fill those in. And now there are no more NAs in those columns. Okay, so that was a good start. We loaded in our data. We made sure everything was kind of loaded in correctly. Our next step is probably going to be to do some visual inspection of the data. So let's look at it and let's see if our assumptions are satisfied. What are some assumptions we might have about this data? What are some relationships we might expect to see, for example, between some of the other variables and the target variable, which is going to be the number of pedestrians? Is there anything we expect to see? Okay, so probably when it's cold, we'll have fewer pedestrians. That's good. What else? Okay, so in the middle of the night, we'll have fewer pedestrians. During commute times, we have many more pedestrians. There are people who walk across the Brooklyn Bridge to work. What about precipitation? Okay, so probably when there's heavy precipitation, we have fewer pedestrians. How about events? So events represent things like anything from Christmas to Mother's Day. How would these affect pedestrians? Okay. So I agree with Ben again. This definitely depends on the event. Some events are, let's say, not necessarily very important, and we'd see the same patterns as any other day. Some events might be work holidays. So for example, President's Day, you'll see very different patterns just because people are not at work. And then other days might be big tourist days, like New Year's, for example. And so you'll see a lot more people than usual. So there are some of these different categories of events, and you want to kind of have that in mind. Now, okay, so let's take a look at this. One good way to look at the data is with something called a peer plot. A peer plot is something that plots every numerical variable against every other numerical variable. And it's just kind of a good way to look at relationships. Because not only will some of these variables be kind of related to the target, which is pedestrians, they might also be related to each other. So let's take a look. For example, we expect that the month and temperature fields are also going to be related to each other. So this is a good way to find what's called collinear variables. And it's very easy to create. So let's do that. Okay, so it's going to take a little time because it's kind of a big data set and we're creating a big plot. By the way, I'm using a plotting library called Seaborn, which is built on top of Matplotlib, but it has some nice built-in plots. So that's why I like to use it. Okay, so here we go. This is a giant plot, and along one axis, we have one numerical variable, and along the other axis, we have the other. Now we can definitely see some trends. For example, we can see a variation of, let's see, where's our pedestrians one? So the top row shows pedestrians. So we can definitely see it varies by whatever's in this field. Oh, okay, this is pedestrians, obviously varies with itself. We can see it varies by temperature, right? By precipitation. But it's kind of big, it's difficult to see anything here. So we're going to make a smaller version of the same plot just by varying some arguments. And again, you don't have to memorize any of this. It's pretty easy to find how to use this. Look up function documentation and create the kind of plot you want. Okay. So here are the top rows pedestrians. Along the diagonal, it shows us not the relationship between two variables, because along the diagonal, it's the same value on the horizontal and vertical axis. Along the diagonal, it shows you the distribution of values for the value for that variable. So here we can see that, let's say, most rows have values in this range, a small number of pedestrians or a moderate number of pedestrians. And then there's kind of this long tail where you have a smaller number of days that have many more or fewer. What did I say was better about Seaborn? It has some really nice built-in plots that it makes really easy to create. And for a lot of plots, it's much easier to create nice plots. Okay, let's look at some of our main predictive variables. So here's pedestrians versus temperature. Okay, so we definitely do see that at lower temperatures, there are fewer pedestrians overall, but it also kind of falls off at very hot temperatures. You don't necessarily have many people crossing the Brooklyn Bridge. Precipitation. So we can see that when there's heavy precipitation, there's less likely to be many pedestrians. There is definitely a time of day effect here. So many more pedestrians during daytime hours. And there's kind of a month relationship. Does anyone remember what's the deal with this big dip in the month distribution? Do you know what that's about? So that goes back to our missing data. So remember, we had about 4 months of missing data, so an entire summer missing. And that's why the distribution of month is not flat in the data. Okay, so we looked at this data. It looks pretty reasonable. Our assumptions make a lot of sense. We can see a little bit of collinearity. For example, there's a relationship between temperature and month, if you look here. So now month is on the horizontal axis, temperature on vertical. A relationship between temperature and hour. So there's some correlation between the predictors as well. Next, we'll take a look at summary statistics. So Pandas has this nice describe function. It will give us summary statistics, so min, max, percentiles, and mean as standard deviation for every numerical variable. Let's take a look at this. What does this tell us? Well, first of all, we want to make sure there's nothing unreasonable. Let's look at pedestrians first. Does this minimum number make sense? So that's good. It's very reasonable that there might be some times when there are 0 pedestrians in an hour, especially during, let's say, a storm. If we didn't have any zeros, that should be a red flag. That might tell us that maybe it's only reporting data for rows where there were pedestrians, and that would obviously be bad for prediction. Okay, the median is a few hundred. 75th percentile is about 1200. And the max is about 3 times that. Okay, so that also kind of makes a little bit of sense. We expect that there are going to be a few extreme events with many more pedestrians than normal. Okay, the statistics for towards Manhattan versus towards Brooklyn are kind of similar. So that is also pretty consistent with our expectations. There are people moving both ways across the bridge. What about the range of temperature? Does this make sense? So this is, let's say, 2 degrees Fahrenheit to 97 degrees Fahrenheit. And remember, our data dictionary told us it's within degrees Fahrenheit. So this looks pretty good. That's a pretty reasonable range for New York City. Okay, precipitation, also a very reasonable range. All of the latitude and longitude fields are basically very similar because all of this data was collected on the Brooklyn Bridge. So it definitely makes a lot of sense that they're all basically the same. The standard deviation is very small. Range of hour looks good. It should be 0 to 23. Range of month looks good too. It is 1 to 12. So everything there looks good. This is our chance to check our expectations against reality and make sure our data looks okay. We can also separately describe any individual field. So I'm showing you this just to show you how you can call these functions on the entire data frame, or you can select a column by name and call the function on that too. Another useful thing is group by. So for example, weather summary was not included here because it's a text string. So you can't really compute the mean of a text string. But it's useful to see how the number of pedestrians vary on average by weather summary. So we can do something like this, and now it tells me, okay, the mean number of pedestrians, or let's actually look at the median. The median number of pedestrians in a clearer daytime period is about 1,400. In a clearer night period, it's about 19. Cloudy is about 140. Fog is about 100. Partly cloudy, also about 1,400. And rain, sleet, snow, and wind is lower. So that all makes a lot of sense, right? Now, one thing we might notice is that some weather conditions are not represented very well in the data set at all. So if you look in the count column, we have a very small number of samples from sleet or from wind, or even from snow or fog compared to any other weather conditions. So we might not necessarily want to trust predictions based on that. Okay. We can also take a look at how pedestrians vary by event. So we can see, for example, Christmas Day has many pedestrians. Columbus Day, which is more of a school day, like a school day off or a work day off, has many fewer. Daylight savings time holiday should not really affect the number of pedestrians, doesn't much. But then there are others, like, for example, someone mentioned July 4th earlier, where we have more pedestrians than normal. Okay. And one thing to kind of be a little wary of is here we were looking at the mean across all hours of the day. If we're looking at the effective holidays, we might be interested in the total number that day. And we can use the ag function to, let's say, in addition to the group function, to get that. So this, for example, tells me the sum of pedestrians grouped by different events. Okay. So I think, let's see, I think we'll wrap it up here. It's 10:30. Now for homework, I'm going to give you an exploratory data analysis problem that you'll do for homework on Colab. And you'll use the notebook I shared about, let's bright space. So you'll do the homework in Colab. And after you do the homework in Colab, you'll submit it to Gradescope. Okay, so the homework will be posted in here. You'll find it in here tomorrow. So the homework will always be posted on Fridays. And you'll do it in Colab. You'll submit it in Gradescope. You can click here to open Gradescope, open your Gradescope account. Now you're going to need to print your notebook from Colab as a PDF in order to submit it in Gradescope. So you can go through this notebook here, and I gave some instructions for doing that. In addition to the exploratory data analysis problem that I'm giving for homework, I'm also going to give you another optional problem that won't be graded. And it's really just because I think it's very interesting and fun. And this is a problem I call the data detective challenge, where I'm going to give you a bunch of data sets that I know have some sort of problem in them. So one of the kinds of problems we talked about today. And it will basically be a competition to see who can find the problem first and post about it on Ed. So that's what you should be looking for tomorrow. And I also have office hours tomorrow morning, so feel free to drop in if you have any questions about the course or want to talk.